Hey, good morning. Second week, I'm back in. Relational databases and SQL. Well, actually, it's SQL, but most people call it SQL, so it's okay if you call it SQL. All right. So, what is this about? Well, this week is gonna be a long one. There's a lot to cover. This is the first time that we try to cover SQL as part of the database week. I apologize. I know that on the calendar it said Mongo because we used to teach Mongo. This is the first time that we officially teach SQL and relational databases as part of the backend. And this is all good for you, right? This is based on feedback from people that are going to give you their jobs, our hiring partners, like hundreds of them. So this is good for you. Very good. All right. So let's see what we have on store. Um, the idea is we have four modules. They're not all the stuff is not on training kit. So we got started in the first module, and the first module would be this week adding data persistence to web APIs, introduction to relational databases and SQL. Then after that, we're gonna learn all about querying data. And querying data means asking questions from the database about the data that we have stored there. We'll see a little bit of that today, but the um, the core of querying data will happen tomorrow. And tomorrow we are going to bring in. Today is just database stuff. Tomorrow we'll bring in our API again, and we're gonna bring some. Uh, I don't want to call it. Let's call it an npm module that is going to let us communicate from Node.js from our Express application with the database that we'll be using. You have seen that in action on last week. You just did not write the code for the database access. It was already there. So this week you're going to learn how to write that code, right? And we'll start tomorrow. Today we're not going to see Node at all or Express. And then it's more of a let's go through the basic concepts so that you could have an idea of what these database things are and relational databases. What do we mean by that? How are they different from things like Mongo that we used to teach? Um, and why is it important for you to learn it, right? And then on the third day, we're going to talk about inserting and modifying data. So tomorrow is going to be about how do I get the data that I have there. And then the next day will be how do I add data in there? How can I change that? How can I remove data from my database? All of that using, of course, your API, right? We're going to be on your API by the time we reach that third day. And then at the end, it's more of a let's have a conversation about, mm, yeah, I have some requirements from a client or an idea for a project, but I have no database. And the way that you design your database, or it's called database modeling, the way that you model your database is really, really important because it's a lot harder to change down the line. So there's some thinking that goes into into the way that you structure your data from the beginning, so that your data can grow and your system can be modified later without too much pain. There's always pain, but without too much pain. And and there are some accepted good practices from the industry, and we're going to talk about those. Also, there are some advanced concepts that we're not going to discuss on the first 3 days, like relationships and how do we do some of those types of relationships. All of that is going to be delegated to that fourth day. So from now, I know you're going to want to learn everything, but uh, we'll go slow. But don't worry, we'll get to everything you need in order to persist data on your web APIs. The CERN stack, yeah, with SQL instead of Mongo. Yep. Um, what's the difference between a database and an API, and how do they work in unison? Oh, we'll see all about that, William. The API is what you've been writing, right? And the database is, well, let me get into it, and then we'll go back to see if you can answer that yourself. But because there's a confusion between a database and a database management system, so I want to make sure that we cover that, and hopefully that's gonna get answered organically. Cool. All right. We're in agreement for now. If not, he's going to come back and ask me again for sure. Yeah, I hope so. All right. So let's see what we have here on training kit. It's not 100% complete. Keep coming back to it because it will get better, right? But this is as the first pass. You get to see you be on the edge of technology, kind of, you know, right there, fringe, on the training kit content. All right. So some motivation here why everything is database in our world, believe it or not. Even some of the things that you have in your kitchen now, they have databases. All of your devices have databases. We picked precisely the database that is in. Not what I mean, Haywood. I mean, you are like on the edge of technology, like way ahead of everybody else. Anyway, so the mobile devices that you have, most of them will have a database called SQLite. So it is the most used database in the planet. That's the one that we're going to be using, not because it is the most used database, but because it's simpler to get started with, and it will give us all the tools that we need in order to practice SQL and have a better understanding of what it is, okay? So of all of the technologies that we use to save data, and to manipulate and have data in our applications. And this is going to go start answering the question for William. What is a database? Well, a database is a collection of data. And some of you may be old enough to remember that we used to have these big books and that would arrive like every year in your house, these big phone books, right? You'll see like the people on TV showing how strong they are by breaking those in half. Probably a gimmick, but those big books, that was a database. It's a paper-based database, but still a database. Whenever you want to go to the supermarket, because we know that we are smart people and we don't just go to the supermarket and start wandering the lanes. Before we go to the supermarket, first we'll make sure that we are completely full, because you should never go hungry to a supermarket because you're going to spend more money. And then you make a list. You make a list of the things that you want to buy, right? And if you go to the same place all the time, you have an idea of what the layout is, and you even organize the stuff that you're going to buy. That little list of things to buy, or that little list that you have on your somewhere around where you could just scribble notes for things that you need to do, those are databases. It's data. It's anything that is a collection of data that you can go back later to reference. That's a database. Of course, we don't care much about paper databases in this class. We care about electronic databases that run on devices or computers, like our mobile devices or tablets or our personal computers, right? So from now on, when we say databases, we mean digital databases running on a computer. Okay? So database is a collection of data, but it's not only in the case of a computer, right? Remember, from now on, we're not talking about paper databases anymore. Now we're talking about digital databases. A database is not only a collection of data, but it's also a collection of data that is organized for easy manipulation and retrieval. Let me lower my mobile device here. Okay, quiet, right? And there are we need, because this is now the data is the information that's there, but we need a way to manage that information. Okay, and a lot of the time the term database is associated with something like Oracle or SQL Server or MySQL or Postgres, but those are not databases per se. They are database management systems, or DBMS. So when we go into this lecture here, we're gonna see the difference between what a database is, what's in the name. Like, okay, it is. In our case, we're going to talk about relational database system. So relational database management system, what is this? We're going to see what SQLite is, a tool that we will use to manipulate those databases called DB Browser for SQLite. We asked you to install those over the weekend. Common database objects, what is going to be inside of it? If you're telling me that database is a collection of data, how is that organized? How is that saved? This is like a Word document? It's like a spreadsheet? We'll see, right? Some of the common database objects or things that exist inside of that database file or files. And how to create databases on something called a table. We'll see what that is. Common data types. We know all about data types on our language. Now we see some data types for when dealing with databases. Understanding a thing called primary key and foreign keys, avoiding duplicates using unique indexes, and the basics of SQL or structured query language. So this is basically the content. Questions? If not, I want to show you the project for today that is going to be really, really small because it's a one-day project as we start tomorrow with a brand new lab. Cool. So what are you going to be doing today on the project in the afternoon? Well, it's going to be about, of course, SQL relational databases, SQLite, and writing basic queries. Remember that tomorrow we're going to learn about more complicated queries. So there may be queries here that you need to come back later and finish, but go as far as you can on it today. Hopefully you'll be able to figure them all out just by reading documentation and the stuff that we'll see in class, right? So first thing is you're going to learn how to create today, use this tool called DB Browser for SQLite to create a database. And so you're going to be asked to create one and add a table to it. So we'll see what a table is and how to create one today. And this thing called a schema is just basically the definition of a table. This is going to tell me which fields or which columns do I want to have on that table. What's the information that I want to save about, in this case, it's an accounts table. So this would be what's the information that I want to save about the accounts. We want to have an ID, a name, and a budget, and there's some information about that you'll take into account when creating those. And then some constraints telling you things like, I want the ID to be the primary key of the table, whatever that means. We'll learn about that later on. And then the next exercise, after you create a database and a table, the next exercise is writing some basic queries. And for that, you don't have to install anything or do it on the tool that we're going to use. You're just going to click on this link right here. This will bring you to a pre-populated database that it's pretty nice. It works on Chrome. It doesn't work, as far as I know, in Firefox. So if you're not using Chrome, I will ask you to install it for this, or Chromium if you're in Linux, because I'm not sure if this is going to work. There are competing standards for relational databases in the browser. I think Firefox decided not to support the standard that uses that this page uses. So it may not work on Firefox. So this provides a database. It's got some data in it, like customers, categories, employees, the details about an order, like all of the lines on an order, the orders itself, products, shippers and suppliers. And you can click this button and it will just restore the database to the original data with all the data that we have, like this 91 record. So if you go on delete, if I want and delete a customer, all I have to do is restore that and it will reset the data to how it was. And this is living in the browser. It's pretty cool. If you go into your, I'm on Windows, so I can now do F12 instead of Shift Command I. And if you go in here, you will see inside of your application. Let me make this. Actually, let's just pop it out for a minute. And we'll pop it back in later. So if we go in here and make this a little bigger, you'll see that in the application tab, there's storage, and you have a whole bunch of storage in there, including something called Web SQL. The one that Firefox pushes as the one that they want to use is called IndexedDB. Chrome supports both, but I think Firefox decided not to support Web SQL. Just, I don't know. So if you see inside of this, you remember that maybe you use local storage back when you were doing front-end development on React. There's also this session storage that we'll see later, but here we care about Web SQL. And inside of this Web SQL, this is where this data that we saw, customers, clients, categories, all of that stuff is in there, is living in the browser. It's like a mini database engine running on the browser. And believe it or not, you know what the engine, well, not in this case necessarily, I'm not sure what engine they're using for this, but for everything else that the browser saves, like when you save your settings and all that, most browsers use SQLite. So you are indirectly using SQLite every time you save let's say that you save a bookmark, right? Or you go and set your settings. Anything that you do that the browser remembers will actually be stored in a SQLite database. Pretty cool, huh? So questions about this project? Well, let me work to this first. So write basic queries, and once you go in there, you'll be able to do things like, let's say that I wanted to see all of the customers. I could say select, and you'll see how to do that later. All of the customers from customers, and then click this button here, and this will give you the results. And check out, make sure that you have the results. Like if I wanted the one with the ID number 4, I could tell it, hey, only give me those where the ID is equal to 4. And run this. There's no ID. Oh, what's the name of the column? I forgot. It's customer ID. Yeah. So customers or customer ID, and this is not case sensitive, shouldn't be. It's equal to 4. I don't remember the field names, customer ID. And there you go. We only get that one. So you'll know whether this is working or not. And if you have an error here, you get an error that is not helpful at all. But besides the point is that you will get an error. So it's pretty straightforward. So that's the tool that you'll use for the exercise. And then you have a few questions. Normally when you're working with databases from the point of view of the developer, what's going on is that you have a whole bunch of questions that you have, information that you need to know. Like in this case, someone may come to you and say, hey, I would like to have a list of all the customers that of the orders that we have. But I'm sorry, for a list of all the customers, I would like to know, probably this is going to be phrased differently. This is going to be like, I would like to know which of our customers are the ones that order the most. Can you give me a list of the top 10 customers based on how many orders they have made in the last year, for instance, right? And this is what this query looks like. It's a list of the customers, in the sending order by the number of orders. And then what you would do is you would pick 20, for instance. And there are ways of doing all that, where you tell the database, hey, I would like to see from my customers, I want to see a list, but I want you first, for each of those customers, go and count all of the orders that they made. Give me that number of orders for each customer. And then I want you to organize those customers based on the number of orders that they have made. Oh, by the way, the ones with the most order, I want those to be at the top. And only give me 10 because I only care about my top 10 customers. Okay? So all of those things that you wanted to know about your business, they translate nicely into what we call a query. And that's what we do. We query the database when we need to get data out. Of course, in order to have that data, we have to also put data into the database, right? And that's another part of dealing with databases. And of course, in order to be able to do this, we need to have the appropriate data saved. Like we need to have the order information, but we need to have a way to relate or connect one order to its customer. And this is where we're going to get, when we talk about data modeling, we're going to talk about those relationships and how do we express those relationships in our database when we design the way that we're going to store the data. Very important that you design your data having an idea, at least, of the information that you will need to extract out of it and the information that your system is going to need in order to function properly. Questions about the project for today. Hopefully you will be able to do all of this today, so that tomorrow we can start working on the second project that has to do with Express. So an API, if you remember, we defined an API in our context, but an API is application programming interface, and basically is a way for systems to communicate, William. So whenever you create a module or anything that has functions that then you could require or import that module, for instance, Axios, right? You do import Axios, and then you say Axios.get. That get is a method, or Axios.post, that's a method too, right? Those methods that you're calling on the Axios object, that's the Axios object's API. It is what people or systems using your piece of code can see and use from that code. I'm sure that Access has a whole bunch of functions in there that you have no access to. But the ones that they publish, like when you say express.json or express, or you say request dot send, those dot send dot whatever that IP, all of those are the API of that particular object, of that piece of code. But in our context, though, we were thinking APIs in a much larger scale, where we say it is some software that is running on a server that we can access over the network, not necessarily through code, doing an import, but over the network, and that is going to publish, instead of publishing functions, methods, and properties, is publishing URLs that we can use to manipulate resources. So this is why I make the distinction, and normally it will say, instead of just saying API, it will say web API. If you see there, is adding data persistence to web APIs. Those are APIs that we build that publish some kind of API, but it's through the web. And the API on the web, it's going to be endpoints, URLs that we can hit. Now, an API can, most of the time, do have data, but not necessarily. It may be something that is simply a calculator, and a calculator doesn't really save any data. It just got a whole bunch of functions that you can execute. When we go into Google and we say timer, and we do that, right, that little application that is going to pop up doesn't really need to persist data about me or anything, right? It's just some functionality. I hit start, and when I hit reset, that's it. It's just functionality that doesn't need to. Well, I don't know whether Google saves everything, but they may be saying, but for this, we don't need a database. Now, if I went into YouTube, what I hope that I publish a video and then somebody else comes into that video and still there, that's data that is persisted. So databases come into place when you need to persist information that way. It's going to be accessible later by you or others. Catching up on Slack. So finally back to one-day projects for only one day. Schema is out, database without the data. Yeah, schema, it's the description of, or the buckets. It's like a variable that you haven't assigned a value to, right? It's there like an object or a constructor function. You haven't added any value to the properties in it, but it defines what the object or the variable is going to look like. So why SQLite instead of MySQL or Postgres? Because it's simpler to work with. When you are just trying to learn the basics of SQL, instead of having to deal with installations, and as we'll see as we go into the introduction a little more, most database vendors, they add stuff to the SQL language that is going to be different per vendor. So picking one, like we use MySQL, I think it was on the first time around, we did like a test for this. It was like a couple of days only just to test it out. But Postgres is also one of the popular ones. You have others, big ones, but they come with extra complexity that could eat a chunk of time, and then you lose what's important, which is practicing SQL and understanding the relational model. Any company that you join or when you go to production, you will pick one. It's also file-based. It's just easier to work with, right? Of course, that means that it's got a lot less features, but the features that we need, they're there. Okay. So every company you work with, they're gonna have a different one, and then what you need to go and learn what's different for that database is gonna be a lot less, and you'll be ready to learn it really, really fast. All right, so let's get to it. So a couple of distinctions, right? Database, collection of data organized for easy retrieval and manipulation. Remember, digital database is on a system. And then the difference is we need software to manipulate that. And that software is what we call a database management system, or DBMS, as you see right here. Hopefully that's big enough. Is that big enough for everyone, please? Yeah, I want to make sure that I cover all the stuff here. But We're going to go a little, because Mongo is a database management system. Something called Redis, R-E-D-I-S, it's also a database management system. They just happen to be two different types of databases, because we have, as we'll see, we have the relational databases, but we also have document databases like Mongo, Redis, which is a key value pair, and you have others like graph databases, um, and other types of object databases, other types of databases that are specialized for a particular problem that you want to solve. Now, relational databases, they've been around for like the 70s. I think 1970 is the first time that Dr. Cott did his introduction of the relational model of thinking about data, right? The relational model. And then from then on, they went on to build the first relational database, and they've been around since then. So that's 48 years ago now that the first database concepts came about, right? And they've been around since then, and it is solid and it's still going on. More relation, out of all the types of databases, relational databases is the one that is used the most, and is a general purpose database. It's something that you could basically adapt to most problems that you'll find. But then there are some problems that it's pretty cool, because a relational database can be used to solve all the problems, but then there are problems that it would be really, really hard or awkward to solve unless you use a relational database. So most systems that you find out there will have some kind of relational database. Even if they have others, they will normally have a relational database, which is why our partners is like, we use relational here, so please give us relational, give us students that can speak SQL. So now that we know that we have database management systems, the software that we use to manage the data, okay, normally running on a server. In our case, we're using SQLite, which is a file base, but still within that file, you have what is called an engine, a database engine. Like the JavaScript engine that we have on the browser. It's a little software that will run JavaScript. This database engine is a little software that will handle the data, but will also have an interpreter or an engine to understand the SQL language. VA understands JavaScript. Relational database management systems understand SQL. That is the language that we use to communicate. Of course, if you go to something like SQL Server, you can also use C# to communicate with the databases, but that's not the standard though. That's special, and you can only use C# for Microsoft databases. Oracle has something called PL/SQL or PL/SQL, but that's an Oracle thing. Only Oracle uses it. So the standard itself for SQL, it's supported by most of the relational database vendors, but then they add extra functionality on top of it and then just rename it to something. The Microsoft version of that is called T-SQL, Transact SQL. And all of the other ones have their own extra functionality that you will learn based on the system that you have. And it's there for a reason, right? It's gonna let you, it's the same as, do I use raw JavaScript to write applications, or do I go to something like jQuery or Angular or React? Of course, if you want to be efficient and fast, and you don't want to be rewriting the same piece of code all the time, you will use some kind of framework or library that has extra things for you. That's what happens with those relational databases. Of course, as I said, we're going to stay here on the basics, on the core of understanding the relational model. So how do we actually, and what are the components? One of the things that we want to see here, what are the components, the things that live inside of a database? And for that, we're going to mention them here, and then I'm going to open the DB browser, or maybe open another tool I have here to show you how another type of database has a lot more stuff that what you have on the SQLite database. You'll see the difference between different systems, even though we're not going to ask you to install any other database, but it's for you to have an idea of, yeah, it changes when you move from one system to the next, but the core SQL language is still the same. And the relational concepts are going to still be the same. So the primary unit of storage on a database, on a relational database, is a table. And you have seen tables, you just don't call them that. You call them spreadsheets, right? It's like a matrix, a two-dimensional matrix that has rows and columns, where each row is going to be an instance of whatever it is that you're saving. If you're saving products, it would be a product, would be a row on that database. We also call that a record. And each one of those rows is going to be broken up or made up of a whole bunch of columns. And that is the data that we want to know about each one of those units, right? So if it's products, maybe I want to know about the product name and the price. Those would be the columns on that table. Those columns are, I think the technical name is fields when you're talking about relational databases. Instead of rows, it's records that have fields in them. So some of the things that you'll find on a database management system are tables, because that's where the data is. Something called an index. And an index is, internally, they are like other tables, but the index is the same as an index in the big book. It's a way that points to places inside of the tables, so that you can find information faster. So what you do is, if you know that you have a table of, let's say, products, but you always do searches on product names, you create an index in that column, in that field, in the name of the product, so that later when you go look for a product by name, it's a lot faster. You don't need to become an expert understanding how indexes work. What's important is that if you know, based on the usage of the data, that you're always searching by a particular field, and you have millions of records, you'll see that the data searching becomes slow. Because if you do not have an index, what would be like if you had a phone book and you needed to find my phone number in there, and you had to start at the beginning, page by page, until you find my name? That would be awful. So what do? You go to the index. You say, oh, L, H, if it's by last name, H, page 565. So you start there instead of going from page 1. So that's what happens with indexes. It's a way for you to make searches faster. So views they behave like it's like a virtual table, but the cool thing about views, and let's go down here. Let's go through the bullet points here, so that I could cover them. And these bullet points are here as a reminder for you, right? So tables, rows and columns. Remember, these is records and fields. Represents a distinct record. A field or attribute that is common to all records. It's the column. Should have each field, each column should have a descriptive name and a data type. And we'll see when we start defining all of the other stuff. So views, what's cool is that they can combine data for more than one table, for 2 or more tables, but also you could filter stuff. Like you could say, yeah, I have a table. You could think of a view as a different representation of the same data that you have on other tables. So I could have a view that look at the products, but that view is like products by region, or maybe products. Think of it as a query that you create, and you know that you're going to be writing that query a lot, so you give it a name. So it's a query with a name that will all return the data filter the way that you wanted it, and coming from 2 or more tables if necessary, right? But there's no data stored there. It's just a way for you to bring data out of the tables where they are. Of course, once you have a table and once you have a view and you give it a name, you can always query it like a table. So it's pretty cool. We'll see how to do that. This is actually pretty helpful. Store procedures and functions. Some database vendors have both. Some have only store procedures. So if you don't have functions there, it's fine. Some vendors call it user-defined functions, UDFs. But at the end of the day, store procedures is what you want to know. So store procedures is some SQL code. Think of it as a little program that you give a name and you save in the database, and then you can execute it later. Calculate taxes. Cool. Maybe in order for you to do that, you have to write quite a few lines of code, of SQL code, like writing JavaScript, like a function. And what do you do when you write a function? Well, it's a whole bunch of JavaScript statements that perform some operation, and then you give it a name, the name of the function. right? It's the same thing with store procedures. Functions you save in your files, in your code, on your source code. These store procedures are saved in the database. So the code to execute them is on the database. It's pretty cool because now you make a backup of the database and all your code is in there. This is really good to solve problems when you have to do calculations over a lot of data. Instead of taking that data and sending it to the client and then have the client process it and calculate the results, you execute all the calculations and all the stuff on the strong server and then only send back the results. So store procedures is something that whenever you have anything that has to deal with a lot of data and complex calculations, you want to do that on the database side and just send the results back. Our procedures blocking, not for your UI, because remember, when you do any operation on the database, that's going to be asynchronous on your side. But on the database is not like, no, remember, it's not a single thread thing. So databases can perform thousands and some of them millions of operations at the same time. So you could be running your store procedure and other millions of things can be happening at the same time on the database server. So your UI is not going to get blocked by executing a store procedure. You're just going to say, hey, go run that store procedure and let me know. The library that we use is going to return promises for all of that. So whenever you go on trying to execute something, it's just going to tell you when it's done. Pretty cool. So triggers, it's kind of it's a special type of store procedure, but is the way that databases do event-driven, right, programming. So let's say that you want to be notified, and this is a real-life example. I joined a company in 2009, and maybe 2 weeks in, I was a CIO. They came to me telling me that some data was being changed or manipulated without the department knowing. And I was new. I didn't understand all the systems there. So I said, yeah, let me investigate that. So the first thing that I do and things like that is I set up what I call a shadow table. So I wired up a trigger that said every time anybody does any inserts, updates, or deletes on this particular table that they're complaining about, I would save the information coming in, the information that was there, and all the information that I could get, like the computer that was done from, was the IP address, what time was it done, what user was logged into the computer, what user was logged into the database. So I logged all of that information with the record the way that it was, if it's a modification, and the way that it ended up after they make the change, okay? And if it's an insertion, the data that they inserted. And if they deleted something, the way that the record was before they deleted it. So I did that, and I let that run for a week or two, okay? And then a couple of weeks later, I went back and I said, yeah, we know what's going on. One of their users, actually, it was an employee. They used to be on their department. They moved to a different department, but he still had access to modify the data. So he was making some changes as part of his work. I mean, it's just that if you are in department A and something is changing and you're not changing it, it's weird, right? So you call attention to that. So things like that are a good place for triggers, because trigger is a silent thing that is running and it's based on events that happen on the database and the user doesn't have to know about. The user doesn't insert, right? And then you can have a trigger that does some operations after that insert happens or before that insert happens. Version control for database, kind of. Yep. It's more like auditing. It's a way that you do audits in some cases, right? Change auditing. But yeah, version control, kind of. This follow along is really short. It's just as we use DB browser or SQLite to look at tables, because this requires a video or maybe some graph, some diagrams or pictures and stuff. We're still working on those, okay? And then we're going to have you, I mentioned a couple of database types. So we're going to have you do a little bit of research to other types of databases, non-relational, and kind of, after you read about them, see how you think they're different from relational databases. So let's go and take a look at a database to start making this a little more real. I'm going to start by, first I'm going to scare you a little bit. I'm going to load the database that I think I have running here. And also, I'm going to take the first look at DB browser for SQLite together. I'm sure that some of you already opened this. So let's go and see if I have some old data here. Let's open a database. Let's open the database for the API challenge that you did. Let's see what we have in there. It's not going to be a lot. It's enough. Okay, here we go. So we have actions, projects, and unfortunately, I haven't found a way to make this bigger other than using the Windows magnifier. So let's see if we can make this bigger. There you go, like that. It's going to look weird, but I find it gets a little laggy. So we see that we have actions. Okay, oh, this is helpful. Tell me if you can see it without the magnifier, because it gets too laggy. So we have the actions, the projects, and other tables there, but those are tables related to, one of them is related to the way that we are accessing the data, and then other ones are related to, are just SQLite stuff that we don't need. Our tables here are projects and actions. Can you see that? Yes, okay. If not, then we'll explain it to you. But what did I do to get here? Well, all I did was I went into this button here that says Open Database. Of course, you go to the File menu, do Open Database, and I navigated through my file system to the data folder on the API challenge, and I clicked on the database and I opened that one. So if I did open again, went into the API challenge data, and then click on the SQLite 3 database that we have there. And the reason it's called SQLite 3 and not .db is because some editors, I think, I don't know if some code editors, not Visual Studio, but some code editors will hide that file, and then students were not able to see it. So we just named the SQLite 3. It's a valid extension anyways. And then after you open the database, you get thrown in here, and this is DB schema may not be visible for you. If you go to the view menu and you click DB schema, this will show up on the right here. So view DB schema, and then you have these tabs down here for the stuff that you want to see, right? And then I select the DB schema. This will always show you the structure of all the tables that you have in your database. So this is now going to start seeing a little more concrete, right? So a table, if we go to actions and we open up, expand actions, we'll see all of the fields inside of that table. So each record in that table will have those fields. It will have an ID, a project ID, a description, a notes field, and some completed flag, another field. It's got a type, and then some definitions about or data that is extra about that particular field. So let's see it now as an actual table, as an actual matrix of rows and columns. So if we go to browse data instead, right? Now we can select from this drop down here all of the tables that we have there. So let's open the projects table, and we have, of course, only one project there. So let's go and select the actions. I think I have like 3 actions there. There you go. Now this is what we're used to. Yeah, we're used to seeing things like that in this way, where the columns have a heading. This is the name of the field, okay? And then each one of these rows right here, that is a record that we have on that database. You shouldn't need SQLite if you download DB browser. I don't remember having to install SQLite in the Mac. I don't know if I had to install it in Windows. I don't think so. Not sure. If you do, you might need to install Python too. What happens if you open DB browser that we ask you to install this tool over the weekend? If you open DB browser for SQLite and try to open the database, does it give you an error? Something that I need to remember. Anybody here has Mac or Windows that could check? Okay, so are you, Mark? Are you on a Mac? Mac. All right. Windows. Oh, cool. Oh, excellent. So Mac and Windows, they work fine. I don't know about Linux. Anybody on Linux? So Joseph, oh, Linux works fine. Perfect. All right. So yeah, you don't need to download SQLite itself, but because SQLite is gonna come with the engine and the little module that we use for Linux might need it. No, no, no. Logan says Linux works fine. So yeah, the DB browser for SQLite. It's let me see if we have the link. It should be here. So it should. If the link is not here, I think we dropped it on Slack. It should be here though, somewhere. So let me post it on Slack. DB browser for SQLite. Hey, Holly, good job. All right, Holly dropped it there. Awesome. This little tool should be a fast download. It's pretty small, pretty efficient too. And they have, even for Linux, they have like the tar.gs file that Linux people use. Source code if you want to see it. They have a portable version. If you don't want to install it, you can just use the portable one. And of course, Windows for 32-bit and 64-bit. Make sure that you download the right one, because the 64-bit will not run if you're using a 32 version of Windows. So download the 64-bit if you're using Windows 10 or Windows 8, because I think those are only 64-bit. Cool. So this is a table. This is where the data lives. And of course, you could have views here. If you see the database structure, for instance, up here, or the one on the right, you will see that we have views, indices, and this is where you have your index. You create an index on one of the fields. It will show up down here with a name. And then you have triggers. What you do not see here is store procedures, because SQLite does not support store procedures. It's okay though, because from the point of view of us, the developers connecting to the database, this is stuff that there is a whole new career dealing with writing programming databases and programming with SQL on the databases. So you're probably not going to start writing store procedures in your company. That's going to be more for the database administrators or the senior developers that are the one allowed to modify the data on the back ends. So you'll be more on the writing APIs and stuff that doesn't have to be with manipulating things on the database. You might not even get access to the database or grants or permissions in order to create store procedures anyways. What if we want to learn to be a database administration too? Excellent. You should, if you like it. It's a very lucrative position. There are not as many positions for database administrators because you can have a team of 100 developers and maybe 2 database administrators, but they do get paid very well. So go for it. Now, becoming a database administrator, you're going to learn a lot more than what we can discuss here. Funny thing is, back in 2000, my first Microsoft certification was actually as a database administrator for SQL Server 2000, I think. So that's a long time ago. And then here we are, writing JavaScript. All right. So other things that we can do with this tool is create a brand new database. If I wanted to create a new one, there's a button here that says new database or file, new database. Also, you can execute SQL statements the same way that we executed a SQL statement on that browser there. We're going to practice as of tomorrow by doing right in SQL Server here, select star from actions, and then Control Enter will execute that. And the results are down here, even though you don't see them. But we did get 3 rows, and they are down here. So we're now accessing the data from within this tool. And this is the data in our database. You can have more than one tab open. So you could create another tab. So you can have some stuff here and then come in here and say, oh, actually, let me see the projects now. Select star from projects, Control Enter, or just click that button over here. That will execute it. And now you have a couple of tabs. You can have as many tabs as you need. Okay. That's the quick intro to the tool that we're going to use. Remember that what's important here is that we're going to learn how to create a table, how to create a database, and use the basic functionality of querying from this as a tool to understand the SQL language, and as a tool to learn about how to the things that we need to take into account when creating tables. So let's go back here. Make sure that we cover everything: views, store procedures, triggers. I said that I was going to show you a different database management system with it. This is SQL Server. And as you see, this reference the server right here. But then, let me see if I can make this one bigger. Nope. So over here, all of these are separate databases. In DB Browser for SQLite, every time you open a database, you are already looking at a single database. Since this is a server, this server can have as many databases as the resources on the actual computer will let it. So you can have multiple databases in the same database management server, database management system, or database server. So this database, look, it's got diagrams. That means that I could double click on one of those things, and it's going to show me a visual representation of, and I could add tables here, and I could have like my diagram of how the database and the tables are related to each other. Okay, this is going to be in Spanish, sorry. But the point is that each one of those squares there represents a table. Let me make this a little bigger. And for each table there, you see that we have the data type for the column and whether it allowed nulls or not. And as part of the data type, you'll see that we also have, in some cases, we have the size. Like in this field right here, this one, it's a varchar, meaning is a string that is a variable in size. So if you have only 3 characters, it's going to store only 3 characters, but it could go up to 11 characters long. But this one down here could go up to 50 characters long, and this one would be up to 80 characters long. So it's not just the data type, like in this case would be an integer, because of this is SQL Server. As we define databases with create tables with DB Browser, you see that SQLite has 4, maybe 5 types. Look at this right here. This is a gamut of types: big integer, binary, beat, chart, day, datetime, and then you have a time one that is separate from the datetime. Datetime 2, datetime offset, decimal, float, geography, geometry. Oh, wow. Look at that. Timestamp, tiny int, var binary, even XML in there. So SQL variant, small money, real, nchart, ntext. All of those are different data types supported by this particular vendor. But if you went and open a MySQL tool to look at the same thing, you will see that MySQL has different types with different names. So what you will do is you learn the basics here, and then depending on the system you use, you learn the data types that that system support on what they recommend you should use it for. So if you know that you're saving money on SQL Server, in other systems, they're going to tell you use decimal, which is a data type that has like 18 precision or something. And Postgres, maybe MySQL would tell you use a decimal. In the case of SQL Server, they have a special type that is designed for money. So you will use that. They will tell you, you can use decimal, but I would say if you want to deal with money, make sure that you don't list those pennies over millions of transactions. Use the money data type because we have it set up specially for that. Cool. So that would be a quick look at what a table looks like before we create one. So let's take a 5-minute break. Come back 10:13. And at 10:13, let's go and create a database and start creating our first table as we move into this second objective of learn how to create a database and a table to store relational data. We're going to do something like this and answer any questions that you may have. So I'll see you in 5. All right, and we're back. So questions. Few messages up. Let's see. Linux might need it. Huh. Weird. So it looks like for Linux, at least Ubuntu for sure, we see here, you have to download SQLite 3. Simon is working on it. I'm sure they probably have one of those packages that you could just do sudo apt-get install SQLite 3, and that's it. So if we know that a database is where the data lives, is not the database management system itself, and we say that SQLite happens to be a file-based, special kind of database that is file-based, and it's got both the engine, the database management system, and also has the data in there. Systems like we just saw SQL Server, they also have the file, right, with the data, only that you have to install the software separate from the files. And then when you create a database, it will create the actual file where the data is going to be stored. Here's a little different. So let's go back into the browser for SQLite, and instead of opening an existing database, we're gonna create one. So I'm gonna create new database. It's gonna go into any folder. So let's go into, let's put it on the desktop so that we can see it. And let's call this Lambda. Actually, let's call it CS11. Let's celebrate, right? CS11, we could give it one of those extension, DB, SQLite, SQLite3, DB3. Let's call it SQLite3 to be consistent. Save that. And that file is going to get created on my desktop. Let me see if I could show the desktop. Well, let me finish. Apparently, it will not let me get out of here until we're done. So this jumped right away into a table creation window. I just made it a little bigger. Yeah. Why? Because if you're creating a database, you're going to store data. So it's assuming that you want to have some tables. You could cancel out of that, or you could just start creating the first table. Let's go and create the first table, and let's create this one here. This is a products table, looks like, right? So ID, name, purchase price, sale price, and category ID. We're not going to add the category ID yet. But I want you to look down here. This is now generating a SQL statement, structured query language. We're going to learn about structured query language in the next section. But for now, this is going to assemble that code for me. So this is a nice way for you to see for the database, how do you create using code instead of using the GUI, the graphical user interface. So let's call these products. And you see that this reads a lot like English. It's like, I want to create a table, and the name of that table is products, right? And then it's got this parenthesis here. And as I add columns or fields inside of my table, the definition for those fields is going to go in there. Oh, Simon, good job. Thanks for letting us know. So now that I have the name for the table, I'm going to click this add field here. And if you have DB browser, I will ask you to open it and find a place and just create this table together with me. So we go through this process together, because you will be asked to create a single table later, same as this on the project. So we have the table. We're going to add a field to it. The first one is the ID. If you by any chance escape and you see that you cannot edit this, just double clicking here on the space where the name is will let you edit it again. Like if it goes like that and you click and you can't change it, just double click on it and you'll be able to change it. So I'm going to call it ID. It's a convention on databases like Postgres or MySQL and SQLite to use lowercase letter and use underscores to separate different letters. In the case of that databases like SQL Server, you will actually write it like this. You will use Pascal casing. So if you want to say something like product ID, it will be like this, product ID instead. So the field will look like this. I mean, you could do it here. It's just not a convention. So let's call it ID. So the ID, and then you have the data types. I said 4 or 5 data types. Here we go, 5 data types. It could be an integer, text. Anything that is a string, an alphanumeric thing, is going to be text. You have blob for binary large objects. This is probably not something you use a lot on SQLite anyways. So we're going to bypass. I'm not sure we want to store audio files or things like that inside here. Maybe I haven't read about it to know. So if we check the documentation, maybe they use this for something else, but normally blobs are used for things like audio and binary data that you want to store there. It's a binary object. So if we want to store pictures and things like that, and you want to store those in the database instead of in the file system and have a reference to it, then it will be in a blob. Anything binary will go here, even a piece of code or stuff like that. And then you have, so integer is a number that has no floating point. Text for things. Real, which is floating point, same as numeric, right? Those are the basic types that you use with SQLite. So depending on your case, you use one of those. So if you want to store money, I would probably go with real. Sounds to me like something that I want to use to store money. Maybe they read the documentation, they will recommend that you use numeric with a particular precision. So this is things that depending on the database, you will go and research and see what they recommend for each type of data that you want to store. So the ID normally in relational databases will be an integer that auto increments. And there are a few things here. If I expand this says not null. Null is like the undefined on database. It's the absence of value, right? But in JavaScript, you have the distinction between a null and an undefined. In the world of JavaScript, null is actually a value that is there, that is null. In the case of the database, though, that means it's empty. There's nothing there. So it's more like undefined. It's kind of confusing, but that's the way it is. So if this is the ID, and this is going to become what is called the primary key, and the primary key for when defining a table, the primary key in the table is the field or the column that identifies each record in a unique way. So every table that you define will have or should have a primary key. In this case, this is going to be our primary key. So I'm going to mark it here as primary key. And look, when I mark it, it tells me the primary key for this table is going to be the ID, separated by a comma. And if I want this key to auto increment, meaning that every time I insert a record, I don't want to calculate myself the ID. Remember when we went through the code, and we were using an array for the demo, I told you this is something that is going to be handled by the database. Don't worry about it too much. This is why I'm going to do a check here of this AI auto increment, and look at that, auto increment automatically. So now you don't have to worry about the ID. You just add the data, and the ID is going to be handled by the database. For now, this is all we need for this field. Since we marked it as a primary key, we don't need to say that it's not null, because it will be auto-incrementing beginning at 1, so it's not going to be null since it's handled by the database. You might do that if you want to, but not needed for the primary key. And there we have created our first field. Now, add field again. Let's give it a name. Call that name. And this is going to be the name of the product, so we're going to make it a text field. In the case of SQLite, you don't have to specify a length. Other database management system may require that you specify a max length for it. So you would say something like at least no more than 20 characters. So what is the U? Good question. And Let's say that I wanted my products to have a unique name so that if you try to add iPad twice, the second time the database will give you an error and it's going to tell you, hey, I already have that product. So it's a free protection that you get to make sure that you don't duplicate data based on a particular field. So if I mark this as unique and I try to insert two products with the same name, the database will bark at, will, tell me, nope, you cannot do that, and protect me from making that mistake. Good question. This doesn't need to be auto increment because this is now text. This is not going to be the primary key. You could have more than one field combined as a primary key, and that would be what's called a composite primary key. But most of the time, those are weird cases. Most of the time, you're going to have a single field auto increment that is going to be the primary key. But you can. I could do this. I could say now my primary key is going to be a combination of both the ID and the name. There are use cases for that. Not in this case. And of course, I want this to be not null because null is actually a unique value. So in this case, I want to say, I don't want this to be empty ever. I don't want an empty, you have to give me a name for that product. So I will make this, we will make this not null and unique. Yeah, that's weird. I don't know why that happened. I think it's when I did the combination, it cannot auto increment that because now you're saying that you're gonna have a combination of the ID and the name, so that will require that you pass both. So yeah, that's why. That's not weird at all. All right, so we have our name. What else do we have there? Well, we had a price and a category. We're gonna leave this for when we talk about relationships, so we're probably not gonna add that today. But we could add let's just add a price, third field, price, to have another type of value. And this would not be an integer because we want decimal places there. I'm gonna make it real until one of you find a better data type for this. I'm gonna say this might be empty if I don't have a price for that product. Yeah, I'm just inserting my products. I haven't figured out what the price is gonna be, so it's okay that it's null. It's not gonna be the primary key. It's not gonna auto increment. It's not gonna be unique for sure, but I can default that to a value. I could say I want the value of that to be 0, like that, and it will add this default 0. So if you don't provide that, I will assume that the price is 0. That may or may not be desired. You might not want it, right? Maybe it's better to have null because you can check and you could say, give me all of the products on my database where the price is null. You could check for that. And that way you know which products you need to fill in. So having it at 0 might not be desired in this case. So we're going to leave it as no default. I just wanted to show you that you could add a default value for that. Like if you know that your clients are all on a particular area because you only serve that area and the area and the postal code is always, the zip code is always the same, you could default the zip code to that unless they tell you a different one, which is pretty nice. Anyways, so here we go. Now we have that table. We have our products table. We could click OK to save it. So questions up until now, and are you able to follow with me? Anybody is not able to follow? Good catch, Thomas, on the auto increment turned off. All right, so I'm gonna click OK, and we have our first table. So if we go back to the database structure here, we could see that we have our products table, and this SQLite sequence, this is what SQLite uses to keep all of those auto increment. So if you have many tables and you have different auto increments on those tables, all of those are going to be kept here. So this is going to be the field and then the sequence. So that's how it knows what the next number is. So we're not going to touch that. We're going to concentrate on our tables only. So let's go into this browse data thing. And look, we have no data here, but we can add data there. So we could come in here. And it looks weird because I made the text larger, so it's easier to read for you. But in yours, probably looks nicer. It's not going to look that kind of weird like that. So if I come in here, I could say, I'm not going to touch the ID. I'm just going to say, I don't know, pen. And the price is going to be, I don't know, $1, $1.19, like that. What is this? Okay. And, oh, I did not click new record. Oh, I didn't. Yeah, there you go. So click new record. We have this one right here. Click new record. No, I already, hey, wait, what do you do? Refresh. Is the data there? Did I not have this auto increment? What's oh yeah. Okay, man. Let me see. Select this record. You should have just added that. I don't know why. Price, pen. Oh, weird. Huh. Weird. So if the ugly thing now is if I do that, it's gonna add the second, it's gonna use that. Ah, okay. I see what's going on. So name would be iPad. Price way too much. I don't know what an iPad is worth, but it's always ended up in 99. So that would be a new record. Let's say iPhone. This is $7.99. Add a new record. What's going on? This is confusing me. The UI is confusing me for this thing. Let's see what data we have so far. Huh. Why is it not adding the values there? Okay, you could see how I'm not an expert using this, inserting data through here on this product. I already have, do I have filter stuff? Oh, did I? I'm adding this on the filter. No. Yeah. Thank you. So yeah, that's not what I wanted to do. So this is the filter. Thank you. So new record, and how do I fill it up? Let's see. iPad. There we go. Here we go. 499.99. Huh. New record. iPhone. So should practice that before trying to demo it. New record. It would be a Mac Pro. Yeah, because everything has to end in 99. All right. So here we go. Now it's better. Sorry, I was doing the filters. So now we have that data. I could go back into our SQL and run it again. And here we go. Notice how I lost, because I was inserting empty stuff, I lost the IDs. That happens in most databases. If you delete a record, or if you add a record, something happens and it breaks, just to be safe, it will move to the next ID. But that's okay. You don't have to worry about those. If you need IDs that you care about, then you will add the field for those. Like if you have special codes that you want to use, then you will add a field for those, but you let the ID just auto increment. Yeah, you will write the changes to the database. It will ask you, like if I try to close it or change to another one, it will ask you if you want to write the changes before you go. This button right here will save it. So if you save that, now that those changes that we made should be on the database. That, oh, I don't have it. It's not showing on this desktop right here. But if we go and open the desktop through the Explorer, you will see that I have this CS11 database that is really, really small in size because it has barely any data. But we created our first database on the desktop there. Other than the filter thingy, the rest of it should be pretty straightforward. So new record, yep, and then add the data here. Remember, no need to add the ID because we have it auto-incrementing. That's it. We could close that and then come back later and just open the database and our data is going to be there. It's just a small file. So far we wanted to talk about the primary key. We talked about that we need to have one, how to add it there. You have seen me type a couple of SQL commands in there. We haven't gotten to those yet, but you have a little challenge here. So let's talk about SQL a little bit and why we want to use that, right? So SQL is the language, the standard language used to manage databases, relational databases. Okay, you could think of sub-classifications within the SQL standard. So there are SQL commands that you use for some things and SQL commands that you use for other things, and they have names, okay? So database administrators normally are the ones using what is called DDL. So let's go down a little bit here and say there is a standard from the ANSI organization, American Standard for Information Thing Interchange, whatever. So so if you go and look for the SQL standard, I think the latest version is from like 2013 maybe. But there is a standard is constantly changing, but most database vendors will have the basic commands that we're going to use here. So should be okay. Those apply to any vendors that you go to, only that they may have little changes here and there, but you will learn those as needed. So I said that you can classify based on what the commands are used for in a few different types of kind of subtypes of the SQL language. And those are the DDL, or data definition language. And this is the stuff that you use to, you see, when we were creating the database on the table, you saw that create table. So that's a create command. So that's a way for you to modify the database objects. So you can also change a table using the alter table, or you could drop it. And when in the case of relational databases, you don't say delete a table or delete an index or delete a constraint, whatever. You do drop, like you drop the table. Apparently, the table is very brittle, and if you drop it, it will break. So it's a drop table is a command to delete the table. So the data manipulation language, this is normally what developers are allowed to write. The data query language and the data manipulation language, this is where you are. This is where you're going to live. And in some cases, you will use this. This has no acronym, so you don't just say TCC. You just say transaction control commands, right? So data manipulation language is when you do insert, deletes, or updates on the data. You're modifying data. And the data query language is when you select the data, which is what you saw me do. Select is the way that you get data out of the database. And then the DCL, or data control language, again, this is the database administrator's world, don't touch that, is where you let people have access to things. And you could use the grant command or the revoke command. I'm missing a little comma here. Grant command and revoke command is like, I want to grant execution access to store procedures on this particular store procedure to this user. So granting permissions is what this part of the spec or the standard is used for. And then you have in relational databases what is called a transaction. It's like the best way of expressing that, if you go to one of those ATM machines and you say, I want to get $20 out, your money should be deducted from the account after you have the money. So both things should happen. If for any reason the machine doesn't have money to give you, it cannot deduct the money from your account until it completes both things, that you gave you the money, or maybe you do a transfer between two accounts, before the money is taken out of one, it should be deposited on the other. So if something happens and the data on the money cannot be deposited on the target account, the money that was taken out of the first account, of the source account, should be put back. In database language, that is called rollback. So when you know that you have to do a few transactions that need to work as a unit, you wrap them into a transaction, and then at the end of that, you say, now I want to commit to this transaction. Look how this sounds a lot like Git, right? Like you're making a lot of changes and you keep adding, and when you're ready to say, yes, I am ready to have this saved into my source control, you do commit, and then you push it, right? Only that in the database world, commit does the push of the data too. And if something happens and there's an error or whatever, then you say, hey, roll back. That means all of the stuff that already happened didn't really happen. It's just you kind of had it there on a temporary space, but you haven't applied it to the data yet. So if you roll back, it's like nothing happened. So it's really nice, and this is one of the beautiful things of relational databases. Oh, there's a note here. As a developer, you will get familiar with DDL, but proficient using DML and DQL. This is mostly where you're going to be. Questions so far? All right, so looking at the repository, you should be able to at least complete the part that's creating the database, right? Add some constraints like mark a field as the primary key, make a field unique, making sure that, oh, this cannot, it's required, get rid of that, ignore that. Let me edit that right away. Live editing, there you go. I'm just gonna call it required. Commit updates. All right, so that is going to be required. You know how to do that. Cannot be empty. And then basic queries. So let's go and start. Remember, tomorrow we're going to talk about more about querying data, but we're going to give you at least enough for you to do some of this stuff. So let's go in here and look at our first command. Questions before we go. So today we live in the world of selects. So this page is going to have, if you want to look at the data that you have there, just clicking in one of those is going to give you an idea, because it will show you what the name of the columns are. So you can click one of those, and this is the data you'll use. So we go into the categories. We have a category ID and a category name and the description. So look at all select right there. So let's write it from scratch. Let me make this a little bigger. So everything begins with a select. You will see a lot of people write select statement like this, where the SQL keywords are on uppercase. Not a requirement. So you could write it this way if you want to. And then the next thing that comes is, what do I want to see out of that? I could maybe I just want to see the category name. So I could just say category name, category name. And then the next part of that is the from. And the from is what says from which table or view do I want to see that data. Remember that there is this other thing called a view. So let's say that I want to see that from the categories table. And there are other things that you could add to this. But for now, if I run this, I will only get the column with a category name. Let's move to customers. Ah, no category name. Cool. But what if I want to see all of the data? Well, all of the fields are represented by star. And the cool thing is that you can combine that too. Let's say that I wanted to have this, and I can reorder the way that I see them. Let's say that I want to see the city first. So I could say city, and then all the data. Look at that, city, and then the rest of the data in to the right, okay? Maybe I want to see the country first. So actually, I could come in here and say country, comma, city, comma, the rest of the data. And now my country, the city, and the rest of the data. Try it out. Let's see if we can play around with this. So what if I want this data, but I want to see all of the records for a particular country together? I want to organize this by the country. Cool. We could come in here and say another one. This could all be in one line. I'm just separating so that you could see the pieces of it, the select and the from. I can now say order by, look at that, with a space in between. Isn't that cool? Order by, and then I could choose what I order. And this could be also a comma separated collection. Like I could say order by the country. And maybe later by the city. So first it's going to order that by the country, and then within the same country, it's going to order by the city, ascending by default. So A is going to show up first, and then within Argentina or Austria, you see that those two are organized alphabetically too. What if I wanted to be descending? Oh, cool. I could say organize it by country, leave it ascending, but the city I want it to be descending. So if we run that, we'll see that Austria now has the S before the G. Give you a little time, because I'm sure you're writing this together along with me. Where's the... What's my examples? I didn't make it. Okay. Any questions so far? Yes. If SQLite is a file in an application, the larger the DB gets, the larger the application gets. That is correct. Is there a way to host SQLite from a separate server? No, not really. If you want to have the database on a separate server, you will use a database server like MySQL or Postgres. Yes, good question. SQLite is a database that you have when you have systems that do not require a lot of data. If you're going to have a lot of transactions that you think this is going to be 25 megs, I mean, don't get me wrong though. Remember that this is not being sent to the client. This is still running on the server. This is going to be on your server side, on your API. So this is that doesn't mean that you're going to be sending a 50 megabyte database to the client. It's going to be sitting on the server the same way that you have images and other files. But it is correct on thinking that if you have a problem with the hosting space of your API, it's going to grow as the database grows. But the actual client that you send is the React application doesn't only gets the data that it needs temporarily, right? Yeah, metadata is a good use for that. So a select is just reading the data that already exists there. We're not inserting any data. The question is this adding the customer ID? The customer ID exists in this table. Yes. So yeah, so for the assignment, you will be creating, you will see that we ask you to create a single table, I think, maybe two. Yeah, one table. The accounts table only, and it's got 3 fields, and add these constraints. Once you're done with that, because this is for you to practice. Once you create one, you create 20. Okay, it's the same process for creating a database. What you want to practice is understanding questions that you need to answer with data and how to assemble the query. And even that you will get with experience as you get more questions. There are more advanced queries that you can write. But here we're just going to cover the basics so that you understand. When they talk about SQL, they mention a select and an insert and an update and a delete. You know what they're talking about. So in the result, the customer ID are adding up. What do you mean adding up? Oh, no. I have this star right here. I'm saying, give me the country, give me the city, and give me everything else after that. It's just me reorganizing the response so that I have the stuff that I want in the order that I want it. So instead of having to specify all of the fields, I just say, hey, I want the country first and the city, and then I want everything else. This is why those show up. If we remove this star from here, it would only give me those two fields. Good catch. I got your question now. How about, because this is letting me now organize by a particular field or a collection of fields in a particular order. And again, I could say descending here. Say by country descending, and then by city descending, or ascending by city. So we could do that. And now Venezuela is the first one, and then in Venezuela, it's ascending. How about filtering? How about me saying, I don't want all of the fields on the database, all 91 records. I only want those where the country is USA. Okay? So in that case, you have select from, and then the next clause is called a SQL clause. It's called where. And where is how we filter stuff. And there are different combinations and operators that we can use for filtering. In this case, I could say where the country is going to be equal to single quotes. You don't use double quotes with databases. USA. Run that. No result. Why? It's USA. Probably USA. There you go. By the way, USA, lowercase and uppercase, could work depending on how the database is configured. When you configure, but this is, you don't need to worry about that. But when you configure the database, there's something that you configure called a collation, like this. And then one of the ways that you configure that is with, there are other things like kind of intensive and whatever, insensitive and stuff. One of them is whether you want it to be case sensitive or case insensitive. So in this case, apparently they have it configured so that it is case sensitive. So when you do the search, you have to have the correct casing for the values. But that's normally not the case. Most of the time, just running USA like that, it will work because most people know that you can't guarantee all the time the data is going to be on the casing that you want. Oh, so where's the customer ID coming from? Oh, they're coming because it's in the data. The data already had those. Yeah. Okay, I got you. Yeah, it's like the USA. We're not adding any of that. This is data that was there. This is why we're starting with this, because that way you have some data that is going to be common to all of you. And it's easy because you can just write your queries here. To upper middleware to the rescue. Good one. Aha, see, yeah. Next question. See, Mark says, would a partial string ever work? Like, what if I wanted to say only US? Cool. So one of the operators that we have, because this is one of the operators, we're saying equal. But there's another operator called like. And then inside here, inside the string, I could say US. That means it's going to begin with US, and using a percent sign, I could say whatever comes after that, I don't care. So by running it that way with a like, now we still get USA. But if I wanted to say, let me see, anything that begins with, uh, wow, there's nothing with a B on the city with an L, or maybe that ends on that have the string en in there, we could say, well, the country like, and then I don't care what it begins with, I don't care what it ends with, as long as en is in there. So this is like whatever whatever is there, any number of characters. So now all of those have a country that has en in there, like Venezuela, we could say right there, Denmark, Sweden. So yeah, Argentina. That is another operator that's very, very useful. Good question mark. Very good. Of course, you could deal with numbers. Like, let's say I want to have my where the customer ID, get out. Customer ID is greater than, let's say, 40. Run that. Yep, and then organize. Well, it's organized already. By the way, you could comment stuff out in most GUIs with double dashes like that. So that means I'm no longer organizing it by that. So probably going to get organized by customer ID by default. Here we go. And of course, you could have greater than or equal to. You know what's important? You see that customer number 40 there? What if I don't want customer number 1 to come in the list? Instead of, because you would think it would be something like this, right? In the case of SQL data, in the case of SQL, it would be, it's not great, it's greater than or equal to. No, it would be less than or greater than 40. So that 40 is not included. Let's do 5, for instance. So we jump 5. So it would be 1, 2, 3, 4, 6. So this is how you say not equal. Everything that you expect is going to work. So I could group this and say, I don't want 5, or where the country is not, let's say, or is Germany, just because it's there. If the country is Germany, this is not going to do what I wanted to, unless number 5 would be in Germany too. That would be convenient. That would be weird. There you go. So let's see, let's make it a little better. Let's say country equal to, and there's a better way of writing this too, by the way. Mexico, run this. So anything in Mexico and Germany is the only stuff that would show up. But if you wanted to do something like this, where you say, hey, I want the country to be in 2 values, this is more for when you have different fields that you want to check for. But if you want to do something like this, you would write it with another operator called in, and then in parentheses, separated by comma, you will add the countries that you want. And this reads so well. It's like I'm reading in English, right? Say, yeah, give me all the customers, give me only the country, the city, and then all of the other stuff from the customers where the country is in Mexico or Germany. Isn't that cool? Yeah, or you could check, you could do or and in that case, if you want to say, give me where the country is Germany and the city is not Berlin, and then you say and. So country Germany. Germany, and then you would do and the city is not. I think is not. I think it's not. I don't remember. I don't remember this not right now. Ha! Wow. You could tell that I don't write SQL anymore. So everything but Berlin should be in there. So the city is the country is Germany, but the city is not Berlin. Like that. And this is because this is not a numeric value, right? This is a string, so you don't use the I don't even know what those are called. The two chevrons. And you could check for null. I mean, we asked you also on Friday to take a look at, yeah, not equal. We asked you to take a look at a tutorial on SQL on the basics, but it was just for you to get into the mindset of what the language looks like. Should be a link here to by the way, the SQL data types on SQLite, but there you go. Here, one, this right here. I think we ask to go all the way to, not this one, no. There's a simpler one. This one right here. So to go all the way to the SQL select, I think it was. So by looking at this tutorial, you could figure out some of the other stuff like the like. Oh, look at the example of the likes, the wildcards that you can use. You can use the percentage, but you can also use, I think a star will represent one character, and all of those are here. The aliases, how to group, how to do unions and all that. All of that stuff is in here. My aim today, though, was to start giving you a feeling of how databases work, and that there is this other language called SQL, and then you could ask questions of the database and then organize that response of that data and filter it any way that you want it. Tomorrow, we go deeper into querying data. What else can I do in order to query data? How can I group the data? What if I want to group all the data by the country and see how many customers I have in that country? And in those cases, down you bring in something called a group by. And you say by the country, okay? But then in here, you have to do other things. Let's say that I wanted to see how many customers I have in there. So I could say count of this as, and this is going to vary a little bit depending on language, on the vendor. I'm hoping that as should work here as quantity, let's say, or customers. Then you run that. Yeah, apparently not. So country can group by country. Oh, like this. There you go. And this will just, what this is doing now, it's just grouping this by the country, and it's counting how many customers are that had the country Argentina, and it's going to give me that number there. But this is what is called aggregation, and there's a whole bunch of those. I could have sums. Like if I had values there, like maybe the ordered totals or something like that, I could sum that. I could average that. I can min max it, like giving the minimum or the max value on that particular field. So all of those are there on the query, on the documentation, but we're going to go through those examples tomorrow as we do querying data. Do you need to push the created DB to GitHub? I haven't thought about that. If we want you to push it, I guess not. I would say more than that, I would like to see you for each of the queries on the repository, add the query that you use to build that. So when you come in here on the README, find the customers for a particular first name, just underneath that, add the query that you use for that. I think that will help our PMs more see where you are on your SQL practice. We will learn how to create databases without the need for the tool. I don't know if you remember, one of you it deleted the database, and I told him to run a couple of commands that created the database and also populated some test data using JavaScript. So we're going to teach you how to do that. So you will not be here a long time creating stuff using this. When building APIs with Node.js, you will probably just have that stuff on your source code on JavaScript, the definition of how the table should look like, and writing a couple of commands, and that's going to, and it's going to do something else for you. It's going to help you migrate the data. It's going to, when you do changes to the data, you could assemble those changes in your source code. So there's going to be a history of all the changes of the database as part of your JavaScript code. So it's going to be on source control. So anybody downloads any version of your code, they're going to have the database structure the way that it was up until that point, which is pretty nice. But this is something that we'll talk about in a couple of days. Yeah, for data changes, as the database changes, you're going to have JavaScript that represents those changes in code. All right. So if you don't have any more questions, go have at it. If you're done with this, you probably will be done with this quickly. Go check out the tutorial. I think I closed it. Shift Command T should recover that for me. Go check out the tutorial. All the clauses there. Oh, between aliases. Well, don't worry too much about joins or inner joins. Just stay on the select, maybe up until insert, maybe up until delete. Stay in those up until the delete over here, because that should be enough for you to complete the exercise. Then tomorrow we do a little more queries, and then we do more about insertion and deleting and all that on the next day. So that's it for me. Thank you for being here, and I'll see you tomorrow.